Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session we discussed about the vectors concept, right? So in today's session also we are going to continue with the vectors topic, so which comes under the motion in a plane. So this is going to be the last lecture of vectors, and again tomorrow we will start the relative motion. So for relative motion I am going to take two sessions, and then next we'll start the projectile motion, where I am going to cover that total projectile motion in 2 sessions. Okay, so relative motion may take 2 sessions or 3 sessions depending on the number of questions we are going to take. Okay, so total motion in a plane, so this is the third lecture. Relative motion, let's consider 3 lectures, and projectile motion 2. So total 8 lectures I have allotted for the motion in a plane. Okay, and we covered already motion in a straight line in the last session, right? Chal. So without wasting much time, let's get into the today's targets. So we have 2 major targets. First one is the scalar product, which is also called as dot product, and the next one is a vector product, which is also called as cross product. Okay, so these 2 are our agendas for today's session, and we are going to do some numericals as well, not some. So we are going to do some like more numericals only. So we'll understand the vectors concept through numericals. Okay. So as usual, for the next 1 hour or 1.5 hours, just be with me, avoid all the disturbances around you guys, and at the end it's very important to prepare your own short notes. Okay, chalo. So let's get into the topic. The first one, what is a scalar product or the dot product? So the dot product is basically represented, so when 2 vectors are having angle between them as theta. So the vector A, this one, and then consider this as vector B. So then let's say the angle between them is theta. So now the dot product is given as A dot B, vector A dot vector B. So which is equals to, so we can write the formula as, so the magnitude of vector A into, so the magnitude of vector B into, so the cos of angle between them, cosine of the angle between them. So this is a formula for the cross product, sorry, dot product. So this dot product, so this results in a scalar component. When you multiply the 2 vectors, so whatever the thing that you are going to get, this is a scalar component, a scalar thing. So the dot product of 2 vectors, dot product of 2 vectors results in a scalar. The dot product of 2 vectors results in a scalar component. Okay, chalo. So now we have, so for example, so let's take the dot product example. So first, the work done is a dot product. So in the 9th grade you learned, right, work is nothing but force into displacement. So where force is a vector quantity and then displacement is also vector quantity. So when you multiply these 2 by dot product, we get the work, where work is a scalar quantity, right? And similarly, so we can write, so the power, so power also you learned in grade 9. So the power is P is equals to F dot V. So the power V is equals to F dot V. So F is a force, V is a velocity, right? Force is a vector quantity and velocity is also the vector quantity. So the dot product of 2 vectors resulting in a scalar quantity. Okay na? So this basic thing is clear, everyone. So the dot product is represented like this. Okay na? So it will not have any direction, only this whole thing is a magnitude only. This total part is a magnitude because it's a scalar thing. Understood? Basic? Chalo. So let's move further. So now there are some special cases which we should understand. So if theta is equals to 0, so cos 0 is going to be 1. We know that cos 0 is going to, if theta is 0, cos 0 is going to be 1. So then A dot B will be equals to, so AB. So the magnitude of A into magnitude of B simply. So if theta is equals to 180, so then A dot B is equals to minus AB. So because cos 180 is minus 1, right? And then if theta is equals to 90, then A dot B is equals to 0. Cos 90 is 0. Okay na? So these are the special cases you should remember. Next, So what are the properties of dot product? So the dot product is commutative. So which means A dot B will be equals to B dot A, because simply the magnitude, right? A dot B, whatever the magnitude you get, so the same B dot A magnitude. Okay, so there is no direction, right? Right? Chal. So and then it's distributive also. A dot B plus C is equals to A dot B plus A dot C. Okay, so this is distributive as well. So and then, so the dot product of any vector with itself. So the dot product of any vector with itself. So write it in the formula mode. So let's say vector A dot vector A, which is nothing but the magnitude of vector A into, so the second vector is also A, the magnitude of A. So the angle between the vector and itself, the angle between that vector and itself is going to be 0 degrees obviously. So simply the magnitude of A, we can write A into, so the magnitude of A, we can write A cos 0, 1. So this is going to be A into A square. So then when you multiply a vector by itself through dot product, so simply the magnitude of its square you can write. The result is going to be magnitude of its square. Clear? So let's suppose if I say, for example, so the B dot B vector I say, so then you can directly write B square or the magnitude of vector B square. So B means the magnitude of B. Okay, clear this part everyone? Chalo. So this is the basic thing. So let's see one question guys. So whenever the question appears, so just pause the video and try along with me. So for two vectors A and B, so they said A and B are the two vectors. So let me write with the white color. So A is a vector and then B is a vector. So the sum A plus B is perpendicular to the difference A minus B. So the difference A minus B. So then the ratio of their magnitudes. So they are asking us the ratio of their magnitudes. So here one thing that you should understand, see here. So if two vectors are perpendicular to each other, so then the dot product is 0. If A vector is perpendicular to B vector, so then their dot product is 0, 0. Remember this thing. So when two vectors are perpendicular to each other, their dot product will be equals to 0. Okay, because perpendicular means theta 90. So cos 90 is 0. So the overall it comes out to be 0. So now here what they are saying, so the sum of the vector A plus vector B is perpendicular to the difference of the A minus B. So what is A plus sum of A plus B? So the sum of A plus B. So they said, let's write this way. So the sum of A plus B. So sorry guys. So the sum of A plus B, this is perpendicular to, so A minus B, right? So now if they are both are perpendicular, so shall I say that A plus B dot A minus B must be equals to 0. The dot product must be equals to 0. If it is one vector, this is one more vector, so then those two are perpendicular, so then the dot product should be equals to 0. Just now we dealt, right? So then, so what is vector A into vector A? So let me write vector A into vector A is A square. Just now I said, right? A dot A will be equals to A square. So now vector A into vector B, so which is minus vector A vector B. So then with this multiply these two. So B vector dot A vector, which is B dot A. So plus into minus, minus B dot B, B square, right? So from here we know that A dot B is equals to B dot A. So this is minus, this is plus, these two gets cancelled, right? So from here A square is equals to, so B square, I sent it to that side. So from here shall I say the magnitude of vector A, or else simply the vector A, the A is equals to B. What does it mean by A? It's a magnitude of A. What does it mean by B? So it's a magnitude of vector B. So those two magnitudes are equal. What they are asking in the question? The ratio of their magnitudes. So the ratio of their magnitude means A by B, which is equals to 1 by 1. So which is 1. So the ratio of their magnitudes is 1. Option A is the correct one. Clear? Chalo. So let's move further. Next. So what's the question says? The next one. the vector sum of two forces is perpendicular to vector difference of two forces. Let the two forces is A plus B. So they are saying that A plus B, the sum of those two forces is perpendicular to vector difference of those two forces. So A minus B. So in that case, the forces are not equal each other in magnitude. No. So they cannot be predicted. So equal to each other. So they are equal to each other in magnitude. So equal to each other means their directions also same. But here directions we can't say. Their magnitudes will be equal. Just now we derived, right? So when the sum of the two vectors is perpendicular to the difference of the two vectors, so then those two vectors magnitude is going to be equal. So that's why those two vectors are equal to each other in magnitude only. So the vector A magnitude will be equals to the vector B magnitude. Clear? Chalo, next. So now, so as we discussed earlier, so we have three orthogonal unit vectors. In the x direction, I cap is a unit vector. In the y direction, j cap is a unit vector. And in the z direction, k cap is a unit vector. So now, the dot product of the orthogonal unit vectors. Let's write the dot product of orthogonal unit vectors. The dot product of the orthogonal unit vectors. So first let's write the I dot I, j dot j, k dot k. So then we'll go for I dot j, so I dot k like that. So first see here, I can write, so the I dot I, orthogonal unit vector means I, j, k. So now I dot I, when you multiply I with the I, so simply shall I write, so the dot product of I dot I, which is magnitude of I into cos of the angle between that vector. So between I and I, the angle is going to be 0. Yes or no? So then, so magnitude of unit vector is 1. And again, magnitude of unit vector is 1. Cos 0, 1. So that's why I can simply say I dot I is equals to 1. Understood this part? I dot I means, so I into cos theta. So however, the vector is dot product with itself. So that's why 0, angle is going to be 0. So then magnitude of I. Unit vector magnitude is what? 1, right? So that's why, so unit vector magnitude 1, 1 and cos 0, 1. So that's going to be 1. So simply I can write from here. So the I dot I is 1. Similarly, the j dot j is going to be 1. And then k dot k is also going to be 1. So this part is clear, right? Chalo. So and the next one more thing that you have to understand, that is, so the I dot j, let's take I dot j, okay? So which is going to be the magnitude of I into the magnitude of j into, so the magnitude of I into the magnitude of j into the, what is the angle between I unit vector and j unit vector? I is in the x direction, j is in the y direction. So the angle is going to be 90. We know that cos 90 degrees is 0. So that's why the 0 into something 0. So therefore I dot j is equals to 0. So similarly, shall I say j dot k will be equals to 0? J dot k will be equals to 0 because j and k are perpendicular again. J is in y, k is in z, right? And similarly, I can write k dot I is also 0. K dot I, because the k is in z direction, I is in x direction. Again, both are perpendicular. So if I dot j is 0, so we can say that the vice versa is also possible because the dot product is commutative, right? So the dot product is commutative. So that's why I can write, if I dot j is 0, so the j dot I is also 0. So if j dot k is 0, so then k dot j is also 0, right? So if the k dot I is 0, so then I dot k is also 0. I dot k is also 0, right? Clear? Chalo. So now, so overall I can write here that in dot product you have to remember, so the I dot I is equals to 1, j dot j is equals to 1, and then k dot k is equals to 1, right? So whereas remaining 0, like I dot j, or j dot I 0. So j dot k 0 and then k dot I 0. K dot I 0. Clear? Understood this part, everyone? Yes? Chalo. So let's move further. So hope this part is clear, everyone. Chalo. So or else I'll give one example. So to understand better, so let me give one example. See here. Let's suppose there is a vector A which has ax I cap plus ay j cap and then az k cap. So this is a vector A in 3-dimensional space. And let's consider there is one more vector, so which is bx I cap plus by j cap plus bz k cap. So then if they ask you to find a dot b, so simply what you can do is the a dot b is equals to, so the respective I caps you multiply, respective j cap you multiply, respective k cap you multiply, because the remaining are I dot j 0, I dot k 0, so this term will become 0. So with this will become 0, so with this will become 0, only this will exist, and here these two will exist, product. So this 0, because the angle will be perpendicular, right, this between I, j, k, understanding? So that's why simply you can write ax dot bx, ax into bx, I dot I 1, so plus, so ay by, then j dot j 1, and then so az bz, k dot k 1, that's it. Okay, clear, everyone? So we'll see the question so that you'll understand even better. Done? Chal. So next, so let's see the question. Pause the video and try it on your own, guys. So here, if a vector is perpendicular to the another vector, so then find the value of a. The simple question, consider the first vector is, so 2 I cap plus 3 j cap plus 8 k cap. Yes. So then, so the another vector b, which is equals to 4 j cap, so then minus 4 I cap. See, write it in the order. This part is very important. So here first j cap is given, so let me write first I cap, minus 4 I cap, then 4 j cap, so then next a k cap. So we have to find the a value. They said these two vectors are perpendicular to each other. So if they are perpendicular, if a is perpendicular to b, so what's our trick we know? Their dot product will be equals to 0. Their dot product will be equals to 0. So if the dot product is equals to 0, so simply we can write what we can write. So the 2 into minus 4 I dot I plus 3 into 4 plus 8 into a must be equals to 0. That's it. This one, right? So this is going to be minus 8 plus 12 plus 8a is equals to 0. So from here we can write, so which is going to be 8a plus 4, right? 8a, 12 minus 8 is 4. 8a plus 4 equals to 0. So from here 8a is equals to minus 4. So then a is equals to minus 4 by 8. So therefore a is equals to minus 1 by 2. A is equals to minus 1 by 2. So 1 by 2 is also there. Choose the option minus 1 by 2. Okay, clear? Chalo, next. So let's take one more question. So what they are saying in the question? So vectors a is given and vector b is given. So are the functions of time. Then value of t at which they are orthogonal to each other. So if they are orthogonal to each other means perpendicular. Orthogonal vectors means perpendicular vector. So vector A is perpendicular to vector B. So don't just afraid by seeing the omega these things. So just follow the procedure. That's it. Okay. Chalo. So what we can write? The A dot B is equals to 0. They said, or else you write like this. So the vector A is perpendicular to vector B as per the given question. So that the vector A dot vector B must be equals to 0. Yes or no? So how do you multiply now? Vector A, vector B. So it's I cap and it's I cap. So I can write the cos omega t into, so here cos omega t by 2. Cos omega t by 2. So I dot I is 1 plus again this one sin omega t sine omega t into, so sine omega t by 2. So now in the basic maths we discussed one formula. So this is in the form of cos A plus cos A cos B plus sin A sin B. It is in the form of cos A cos B plus sin A sin B. So whose formula is cos of A minus B? Whose formula is cos of A minus B? Yes or no? So then this is going to be A, this is B. So this is A, this is B. So what is cos of A minus B now? So the cos of A minus B, in place of A we have omega t, in place of B we have omega t by 2. So then as I said earlier, this dot product must be equals to 0. So this dot product must be equals to 0. So I can write, so the cos of omega t minus omega t by 2. So which is omega t by 2, which is equals to 0. The cos of omega t minus omega t by 2, which is equals to 0. So which is nothing but cos of omega t by 2 is equals to 0. So then cos of which angle is 0? Cos of which angle is 0? We know that cos 90 degrees. So answers are in pi. So let's take cos pi by 2. Let's take cos pi by 2. Cos 90 is 0, right? So then by comparing, I can say that omega t by 2 is equals to pi by 2, right? So what do I require here? So I required time. So then omega t is equals to pi. From there, so the t is equals to pi by omega. The t is equals to pi by omega. 0, no. Pi by 4 omega, pi by 2 omega, pi by omega. Option D. Clear? Understood, guys? Chal. Let's move further. So don't afraid by just looking at the question, just understand properly. A particle moves so that its position vector is given. So this is a position vector, fine. So then where omega is a constant, so then which of the following is true? So what they are saying, velocity is perpendicular to r and acceleration is directed towards the origin. So velocity is perpendicular to r and acceleration is directed away from the origin. So velocity and acceleration both are perpendicular. Velocity and acceleration both are parallel. Okay. So first they gave the position vector. So the first thing is they gave the position vector. So let's write the position vector. So the position vector r is equals to, see carefully. So cos omega t I cap, let me write that I cap, cos omega t I cap plus, so the next one, sin omega t j cap, sin omega t j cap. So now in every option, see here, velocity, 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 acceleration, acceleration, acceleration. So I need these two terms first. What is the relation between velocity and acceleration? I should know. So for that, I know the position vector. So can I find the velocity vector? How do you find the velocity vector, guys? So velocity is nothing but differentiation of the position, right? So that's why I am differentiating the position vector with respect to time. So which is nothing but d by dt of, so I can write cos omega t I cap plus sin omega t j cap, sin omega t j cap. So if you want, you can split this. So d by dt of cos omega t I cap plus, so d by dt of sin omega t j cap. Yes, basic maths we discussed in detail. So here cos omega t differentiation is going to be minus sin omega t. Cos omega t differentiation is going to be, cos theta differentiation is minus sin theta, right? Into, so again the omega t is differentiable. So the omega t differentiation is omega. Chain rule, omega t differentiation is again omega. So into I cap, let it be, plus, so d by dt differentiation of sin theta is going to be cos theta. So which is in place of theta we have omega t. So again omega is a differentiable term, right? So that's omega t is a differentiable term. Omega t differentiation is omega. So which is j cap. So that's why this is going to be minus omega into sin omega t I cap plus, so omega into cos omega t j cap. So this is the velocity vector. So let it be. Just mark this one. Okay. So now let me find the acceleration vector here. So let me find what is the acceleration vector. So how do you find the acceleration vector? Acceleration is equals to, so the dv by dt. Yes or no? So here d by dt of what is the velocity vector we got? Minus omega into sine omega t I cap plus, so my omega into cos omega t j cap. Yes or no? So again differentiate the two terms separately, d by dt of minus omega into sine omega t I cap. So plus d by dt of omega cos omega t j cap. Omega cos omega t j cap. So now if you take minus out, so and then omega is a constant, so sine omega t differentiation cos omega t, right? And again omega t is differentiable, omega t differentiation is omega, so I cap plus, so here omega is constant, take it out, cos omega t differentiation is minus sine omega t, and omega t is again differentiable, whose differentiation is omega j cap, right? So from here I can write minus omega square, so see here minus omega into omega square, so we into cos omega t I cap plus, so plus into minus, plus into minus. So here again omega into omega square sine omega t j cap. So this is a acceleration vector. So we have got acceleration vector and we have got velocity vector. So first check, they said in the first option the velocity is perpendicular to r and acceleration is directly directed towards the origin. So first check whether velocity is perpendicular to r or not. So if the velocity is perpendicular to r, the dot product is 0. First check velocity is directly is perpendicular to r. So if the velocity is perpendicular to r, the v dot r should be equals to 0. The dot product of velocity and position vector should be 0. So what is the velocity vector that we got? Minus omega, so let me write clearly, so the v dot r is equals to, so minus omega sine omega t, right? Sine omega t I cap, sine omega t I cap, so plus omega cos omega t j cap, omega into cos omega t j cap. So this is the first vector, which is v vector, dot, so then a r vector, what is the r given vector? Cos omega t I cap plus sin omega t j cap, cos omega t I cap plus sin omega t j cap, right? So from here I can write, so the I dot I must be I dot I plus j dot j. What is I dot I? So this into this, right? So minus omega into sin omega t into cos omega t. I dot I is 1. So just write it this one. So plus, so j dot j, omega cos omega t into sin omega t. The j coefficient is sin omega t. If you observe here, this is sin omega t cos omega t into omega whole minus, here also sin omega t cos omega t omega. So this whole thing is minus, this whole thing is plus, and both are same. So shall I say this total thing comes out to be 0. So that means the velocity is perpendicular to position. The velocity is perpendicular to position. So this part is clear. So the first one, the velocity is perpendicular to r. This is correct. This part is correct. Velocity is perpendicular to r. This part is also correct. Velocity and acceleration we can't say. So velocity and acceleration both are parallel. So we can't say that. So we got these two options, and then acceleration is directed towards the origin or acceleration is away from the origin. How do we get this? So how do we get the acceleration? See, observe the acceleration. See here. So the acceleration vector, shall I write? See, shall I write minus omega square? I am taking common. Minus omega square I am taking common. So that here I will get cos omega t I cap plus sin omega t j cap, sin omega t j cap. So then I can write it like minus a is equal, a vector is equals to minus omega square. So this one, see here, cos omega t I cap plus sin omega t j cap is nothing but r vector, is nothing but r vector. So the acceleration is equals to minus omega square r. So what does that mean? So the acceleration is equals to, if it is the vector, so the acceleration is equals to minus omega square r. So which is nothing but, it is towards the origin. The acceleration is, you will understand its equation when we deal with the SHM, where in SHM the acceleration is equals to minus omega square x. So which is nothing but, so the particle is moving towards the origin. It is moving towards the origin. So here also the same thing. So the acceleration is towards the origin. The acceleration is going to be towards the origin. So this is the correct option, option A. Understood? Just the position vector is given. So mathematical part you have to do. So we found what is v, velocity vector, then what is acceleration vector. Okay, so then we did what is v dot r. V dot r we directly got 0. Okay, clear? Chalo, next. So now one more thing, how do we find the angle between the two vectors? So the simple logic, use the dot product. Let's suppose a and b are the two vectors and the angle between them is theta. So then the a dot b is equals to, we can write ab cos theta, or magnitude of vector a into magnitude of vector b into cos of the angle between them, cos theta, right? So from here, shall I write the cos theta is equals to a dot b by, so the magnitude of vector a into the magnitude of vector b. Simply, yes or no, cos theta is equals to magnitude of vector a, a dot b by magnitude of a into magnitude of b. So from here the theta is the angle between those two vectors, which is nothing but cos inverse of a dot b by, so the magnitude of a into the magnitude of b, or simply you can write ab in the denominator. Simply you can write ab in the denominator. A means magnitude of vector a, b means magnitude of vector b. Okay, clear? Chalo, let's move further. So let's take the sixth question. So find the angle between two vectors. So the simple thing, first let's consider the vector a is I cap plus j cap, and consider this as a vector b, which is j cap plus k cap. So then we know that the cos theta is equals to a dot b by, so the magnitude of vector a into the magnitude of vector b. So first find these values. So what you do is, first calculate what is a dot b. First calculate what is a dot b. So what is a dot b? A vector is I cap plus j cap. So into dot j cap plus k cap. So j cap plus k cap. So I can see that I dot j 0, I dot k 0, and again j dot j 1, j dot k 0. Yes or no? I dot j 0, I dot k 0. So j dot j 1, j dot k 0 again. So therefore a dot b is equals to 1. So this we got. Then we have to find what is the magnitude of vector a. So how do you find the magnitude of vector a? So the square root of its ax. Ax means component of, coefficient of I cap. Coefficient of I cap 1. So ax square plus ay square, coefficient of j cap 1 square, which is nothing but root 2. So similarly, what is the b? So magnitude of b. So square root of, so x 0, there is no I component. So and then ay square. Ay means component of the coefficient of j cap, which is 1 whole square, plus the coefficient of k, so which is 1 whole square. So this is going to be root 2. So that's why substitute these values now. So we can write a dot b is however 1 by, so magnitude of a root 2, so magnitude of b root 2, so which is going to be 1 by 2. So cos theta is equals to 1 by 2. So from here theta must be equals to 60 degrees. Cos 60 is 1 by 2, right? So that's why it must be 60 degrees. Option C. Understood, guys? Chal, let's move further. So again, the same question. Can you solve this question? Take it as a homework. Consider this as a question homework 1 and do it on your own and comment your answer. Comment your answer, guys. So those whoever comment, I'll take their names in the next session, and let's applause. Let's give a big round of applause for them in the next session. Okay. So comment your answer for this question. Simple question. Vector A is given, vector B is given. So simply you have to find the angle between those two vectors. Cos theta is equals to A dot B by magnitude of A into magnitude of B. That's it. Okay. So let's take the one more question. Question number 8. A particle moves in the xy plane under the influence of a force such that its linear momentum is given. Okay. So linear momentum. So the P, which is a function of time, is given, which is A into cos kt I cap minus sin kt j cap. So fine. So where A and K are constants, so then the angle between force and momentum. Okay. So here momentum is given. So first we have to find what is force. So in the next chapter, that is NLM, Newton's laws of motion, where we come across this formula, or in grade 9th also we have discussed about this formula. So the force is nothing but the rate of change in momentum. Yes or no? So the rate of change in momentum, so which is nothing but the force, yes or no? So from here, so simply differentiating the momentum, we get the force. So now d by dt of, so what is this momentum we got? So the momentum is simply, so A, so then let's write this way. So this big brackets and then again A into cos kt I cap minus sin kt j cap. Sin kt j cap. So you are differentiating with respect to time, guys, here. Okay na? So first A constant, then so then I am differentiating A, take it out. So then d by dt of, so let's first differentiate the cos term. So cos kt I cap, so then minus differentiate d by dt of sin kt j cap. Sin kt j cap. So just the mathematical part, be careful with that. Okay. Chalo, see here. So then A is outside total. So you know that cos kt differentiation is going to be minus sin cos theta differentiation minus sin theta, minus sin, in place of theta we have kt, right? Again kt differentiation, chain rule apply. Kt differentiation is going to be k. Yes or no? So I cap minus, so differentiation of sin theta, which is cos theta. So cos theta, in place of theta we have kt, and then what is the coefficient of t? So which is k. Coefficient of t is k, right? So then j cap. So this is a, so we can write, so the force vector from here. So the force vector, let me write it in the next slide better. So then they are asking what is the angle between force and the momentum. So let's write. So we have got the force vector is equals to, so A into minus sin kt minus k sin kt I cap, so minus k into cos kt j cap. Cos kt j cap minus k into cos kt j cap. Yes, fine. So and then they are asking us the angle between, what is the angle between force and momentum. So this is the force, and then what is the momentum that they gave? So momentum is simply, so A into, so k cos omega t, cos kt, sorry, k into cos kt I cap. This is cos kt I cap, so minus sin kt j cap, right? So minus sin kt j cap. So yes, so now we have simply two vectors, that's it. So we have force vector, we have momentum vector. Now we have to find the angle between force and momentum. So then simply can we write, so the cos theta is going to be the f dot p by, so it's going to be magnitude of f into magnitude of p, magnitude of f into magnitude of p. So first we got the two vectors. So now you can find their vector product and you can find their magnitude. From here, can you take this as the homework? Again the simple part, because you should try it on your own, guys. I already discussed what is, how do we get the force from the momentum? We already discussed, right? Force is equals to dp by dt. We got it. What's the force function? We got it. And momentum function, we got it. Just find the angle between the two vectors now. That's it. Okay. So take this as a homework. So let's consider this as homework 2. So again, comment your answer. Clear? Understanding? Just try, pause the video and try. If you are not getting, just comment it down. Sir, I did not understand. So how to do the procedure? So again, I'll take this question in the next class. I'll explain that. But before that, first try it on your own. Okay. Chalo. So then, the angle made by the vector with the coordinate axis. For example, so in the xyz plane, 3-dimensional plane, I am taking a vector A. So this vector A will have now, so the x component in the x direction. Yes, this vector A will have y direction in the j cap, y direction in the y component in the y direction, and then z component in the z direction. Yes or no? So now see the title, angle made by a vector with its coordinate axis. So what is the component of x? Component of A, this is ax. The component of A, this is ay. The component of A along z is az. So now how much angle this ax is making, this how much angle this ay is making with the coordinate axis, and how much angle this az is making with the coordinate axis. That's what we are talking about. So which is nothing but simply you can write, so the cos alpha. So let's suppose the ax is making an angle alpha with the x axis. So the cos alpha is going to be simply ax by a. Cos alpha is equals to ax by a. If you want, you can write that, right? So because cos alpha means adjacent by hypotenuse. Adjacent is what? In this triangle, see here. So this is a right angle triangle. Cos alpha, a adjacent ax, hypotenuse vector a. That's it. So similarly, you can write what is cos beta. Cos beta. So cos beta is nothing but this side. So you just finish this triangle. So cos beta adjacent. Adjacent is ay by vector a. Ay by vector a. And then cos gamma. So gamma. So with respect to the x axis, with respect to a. So it's going to be, so just imagine this way, like this. This is a vector. So then it's going to be az by a. Az by a. So from here you can write, if you need, you can write the component of x is going to be a cos alpha. The component of vector y, the vector a in the y direction is going to be a cos beta. So here the component of vector a in the z direction is a cos gamma. A cos gamma. Okay, clear? Now, so now one important relation you should remember here, that so here let's say the cos square alpha plus cos square beta plus cos square gamma. So what is this result? So just let me derive this. So cos square alpha, what is cos alpha? Cos alpha is ax by a, right? So this is going to be ax by a whole square plus this is ay by a whole square, and then this is az by a whole square, right? So from here, so if you do further, so in the denominator all are a square, so that's why I am writing a square. So in the numerator it's going to be ax square plus ay square plus az square. Simply see, we are doing the square. Ax square by a square, ay square by a square, az square by a square. So then I took the LCM, a square. So then it's going to be ax square plus ay square plus az square. So now the thing is, we have the vector, right? What is the a vector is given? the vector A is ax I cap plus ay j cap plus ay az k cap. Now from here, shall I write, so the magnitude of the vector A is going to be the square root of ax square plus ay square plus az square. Yes or no? So if I squaring on it on the both sides, so the magnitude of vector square, which is nothing but a square, is equals to ax square plus ay square plus az square. Yes. So from here I am writing, so in place of ax square plus ay square plus az square, I am writing a square. So therefore a square by a square, so which is nothing but 1. So this is just the procedure, but I am asking you to remember this part. So if any vector is making an angle alpha with the x-axis, beta with the y-axis, and then gamma with the z-axis, so then the cos square of that angle made by that angle made with the coordinate axis, cos square alpha plus cos square beta plus cos square gamma, so this whole thing comes out to be 1. Okay, so remember this 1. Clear? So let's move further. So let's take the question. So what's the question says? See here, a vector A makes equal angle with x, y, z axis. So vector, let's suppose this is a x, y, and then z axis, x, y, and then z axis. So let's consider, so the vector A is this one. This is a vector A. It's make equal angle with the all three axes. Let's suppose with the x, let's suppose it is alpha. So with the y it is beta, and with the z, so here let it be beta, and with the z let it be gamma. So now what they are saying is all three angles are equal. Alpha is equals to beta is equals to gamma. They said equal angle with the xyz axis. So values of x component in terms of magnitude of A will be. So we have to find what is the value of its x component. So what is the value of its x component? The first thing is, so we know that whenever three coordinates axis angles are known, the cos square alpha plus cos square beta plus cos square gamma should be equals to 1. Yes or no? So from here, so all three are equal. So then shall I write cos square alpha in place of beta also? I will write alpha. In place of gamma also I will write alpha. Yes, because they are asking us the x component. So that's why I am writing everything in terms of x. Like alpha is the angle made with the x-axis, right, between the vector and the x-axis. That's why in place of beta alpha, in place of gamma also alpha. So this is going to be 3 cos square alpha, which is equals to 1. So then cos square alpha is equals to 1 by 3. So from here cos alpha is equals to 1 by root 3. Root 1 is 1 only. So that's why cos alpha is 1 by root 3. So but that's not the question. So what they are saying, the value of its x component. What is the x component? The ax is equals to a cos alpha, right? What is the value of x component? The ax is equals to a cos alpha, right? So that's what I wrote. Ax is equals to a cos alpha. So then a is the magnitude of a into, so we have got cos alpha value as 1 by root 3. So simply it's going to be a by root 3. It's going to be a by root 3. Option A is the correct one. Understood? Clear? Sure. So now, so this part is also important. So the component of one vector along the another vector. So the component of one vector along the another vector. So see here, already we discussed in the last class through the questions. So now let me give you the concept as well here. So the component of vector B along A. So there will be two. One is the scalar component, the other one is the vector component. So in the questions they will ask mostly this one. This is frequently asked. This part they will ask frequently. Okay, chalo. So the component of B along A. So what will be the component of B along A? So B vector is like this. So compulsory the B will have, so this side component B cos theta. So the component of B along A is going to be B cos theta, I can write. Just understand the procedure. So this is a vector B. So this vector B has two components. So this side b cos theta and this side b sin theta, this side b sin theta will be there. So now what is the component of b along a? Along the a direction we have b cos theta. The component of b is b cos theta. So now what I am doing is, let's write b into, in place of cos theta, shall I write a dot b by ab, a dot b by ab simply. Cos theta is the angle between the two vectors, which is a dot b by magnitude of a into magnitude of b. ab means magnitude of a, here magnitude of b. So here b cancel. So then vector a by a into vector b. So that let's write the vector b first. So what is this one? Vector a by magnitude of vector a, which is nothing but the unit vector of a. So therefore, so the component of, I can write the component of b along a, along vector a. So how can we write? So the component of b along a means vector b first, along a means take the unit vector of a, take the unit vector of a. So this whole thing is only magnitude, we are not talking about the direction, just scalar component we are talking about. Okay, so to make perfect, so let's write, if I say the component of vector x along y, just to write it easily, this is the procedure, but just to write it easily, so I am telling you the shortcuts here. So component of x, vector x along y. So vector x component, let it be, let's write vector x along y means y unit vector. Along means direction, direction will be given by unit vector. Along y means y cap. Okay na? Or else let's write, so if I say the component of, so vector k along vector m, so that means, so vector k and then along m vector unit cap, m vector unit vector, so which is nothing but it gives a direction. Understood? This is a scalar component. So now if you need the vector component, so the direction, it will have the magnitude, it will have the magnitude as well as direction, it should have the magnitude as well as direction. So the component of b along a, so which is b a, so this is simply the magnitude, this whole thing is a magnitude, b along a, and then direction, what is the direction? The whole thing, this whole thing direction will be along the a direction, so that's why a cap. So this is very less asked unless and until they mention, so the vector component, so don't take this one. So if they mention, take this, otherwise so just go for the previous thing only. Okay na? So till here clear everyone? Next, so done. So the, or else let's write, I'll give one more example, see here. So if I say the vector component of b, or else x along y, x along y, okay, vector component of x along y, so it should have the magnitude. What is the magnitude? Vector x and along y means y unit cap, this whole thing is a magnitude, and then vector component they said, so that's why again direction, so the direction is along the y. Okay, so or else for the same thing if I write, what is a scalar component of x along y, scalar component x along y, so this is going to be simply, so the x vector and y cap, that's it. So this is the magnitude, that's it. Scalar component means only magnitude, so vector component means again for this magnitude, so add the direction, that's it. Clear everyone? Sure. So let's move further. So take the question. So component of vector a along the another vector, consider the vector a is 2i cap plus 3j cap. So now let's consider the second one, let it be the vector b, which is I cap plus j cap, I cap plus j cap. So what they are asking, the component of vector a along vector b. So the component of a along b, a along b. So how do you write? A along B. Along B means B unit vector, right? So see here, there is no direction mentioned, only magnitude in the options. In every option there is only magnitude. That's why simply consider the scalar component. Simply consider the scalar component. So then now your duty is to find what is vector A. We already know. So what is vector A? We already know. So we have to find B cap. So what is B cap? B cap is vector B by the magnitude of B, right? So what is the magnitude of B vector? Magnitude of B vector, so which is square root of coefficient of I 1, coefficient of j 1. So there is no k, so just write it like this. So this is going to be root 2. So vector B, what is vector B, guys? So I cap plus j cap by, so magnitude of vector B, it's going to be root 2. So that's why, see here, so the vector A, which is 2i cap plus 3j cap, 2i cap plus 3j cap, so into, so what is the B cap? So what is B cap? I cap plus j cap by root 2. So simply do the dot product in the numerator. So 2 into 1 2 plus 3 into 1 3, I into I, j into j, right? So by root 2, so which is nothing but 5 by root 2. Option 5 by root 2. So option A is the correct one. Clear? Done? So now let's come to the next part, that is the vector or cross product. Printing mistake, this is a product. Okay, so vector or cross product. So now the simple thing, so A cross B, the cross product is denoted by A cross B, so which is given as A cross B, so which is AB magnitude of A into magnitude of B into the sine angle between them, which is sine theta. So the AB sine theta, A cross B is equals to AB sine theta. So this vector product will have the direction as well. So that means whatever the resultant, it's going to be a vector again. So the cross product of two vectors results in a vector. Cross product of two vectors results in a vector again. Results in a vector quantity. So that means it will have the magnitude and the direction. So this whole thing is a magnitude now. This whole thing is a magnitude. So now the direction is given by some unit vector. So the direction is given by some unit vector. This gives a direction. This gives a direction where n cap is a unit vector. So now the examples of the vector product are torque. Torque is equals to R cross F. R is the displacement, F is the force. Both are vector quantities. If you do the cross product, so the resultant torque, which is also a vector product. So this will come across in rotational motion chapter. Okay, and angular momentum. So angular momentum is L. So L is equals to R cross P. R is the displacement and then P is the momentum. So again, which is going to be a vector quantity. L, angular momentum, is a vector quantity. Torque is also a vector quantity. So simply write the dimensional formulas. You already know torque dimensional formula and angular momentum dimensional formula. You just write it down. Just pause the video and write it down here itself. Okay. Chal. So now the thing is, how do you find the unit vector here? How do you find the unit vector here? So first thing, I can say that the A cross B, like two vectors, consider these are the two vectors. So this is one vector and this is one vector. So now A cross B means, so where direction, to find the direction, so you just use the right hand thumb rule. What is right hand thumb rule? So A to B, curl your fingers. This is a B vector, this is a A vector. Okay. So now what you do is A to B, curl the fingers. So this is a A, this is a B vector. A to B, curl the fingers. So then thumb gives the direction. Okay now. So is there a separate slide for that? No. So then direction of the direction of the resultant, the direction of A cross B, so will be given by, so curl your fingers, curl fingers from A to B, then thumb gives a direction, thumb gives a direction of A cross B. So simply, so these are the two vectors. Let's suppose this is A, this is B vector. So now from, if you are doing A cross B, A to B, curl your fingers, A to B, curl your fingers. So then thumb gives a resultant. So the thumb is this one. Okay, if you are doing B cross A, so curl your fingers from B to A. See here. So B is this one, A is this one. So if you are doing B cross A, so simply do one thing. So B cross A, see here, B is this side, A is this side, B cross A. So the thumb gives this side. So that's why, can we say the A cross B is not equals to B cross A in this? The A cross B is not equals to B cross A, guys. So but the magnitude of A cross B will be equals to the magnitude of B cross A. The magnitude of A cross B will be equals to magnitude of B cross A. Can I understand this logic? How do we find the direction, and then how do we represent the A cross B? It will have the magnitude and the direction. Okay. So and then one more important thing. So the whatever the A cross B, it will be perpendicular to vector A. The resultant A cross B, it will be perpendicular to the vector A as well as it will be perpendicular to vector B also. The resultant will be perpendicular to the two given vectors. Just imagine, this is a vector A, this is a vector B. So let me hold like this. So if these two are in a plane, let's consider this is a plane, notebook, let's suppose these two are placed on the notebook. So then if you are finding A cross B, see here A cross B, so then the resultant A cross B is in this direction. Yes or no? The resultant A cross B is in this direction. So this A cross B is now perpendicular to this A and it's perpendicular to B. See, consider this whole thing as a plane. So for this plane, this resultant is what? Perpendicular. So A is in this plane, B is also in this plane. That's why the resultant of the two vectors, cross product of two vectors, will be perpendicular to their individual vectors. So A cross B will be perpendicular to A and A cross B will be perpendicular to B. So from here what we can write? So the A cross B dot A is equals to 0. Yes or no? The dot product of two perpendicular vectors is 0. And then here also we can say the dot product of two perpendicular vectors A cross B dot B is also 0. The dot product of two perpendicular vectors. This is one vector and this is one vector. Their dot product is 0. Understood about the cross product, guys? Again I am discussing. See here. So first the formula is A B sin theta. This is simply the magnitude and it will have the direction also. So how do you find the direction of the resultant? Use the right hand thumb rule. So if you are doing A cross B, so curl your fingers from A to B. So then thumb will give the resultant. If you are doing B cross A, curl your fingers from B to A, then thumb will give the direction. So as you could see, A cross B is this side, B cross A is this side. Just I am taking the example. So obviously I can say that A cross B will not be equals to B cross A, but their magnitudes are same. Their magnitudes are same. B cross A means you write magnitude of B into magnitude of A into sin theta, but the direction is going to be different. A cross B is this side, B cross A is this side, downwards. So that's why A cross B is not equals to B cross A, and their magnitudes are equal. A cross B is magnitude is equals to B cross A magnitude, and whatever the resultant vector is there now, so that vector will be perpendicular to two given individual vectors. A cross B is perpendicular to vector A and A cross B is perpendicular to vector B as well. So or else if you want, you can write like this. The A cross B will be equals to minus B cross A. This is valid. This is correct. This is valid. A cross B is equals to minus B cross A. So reversing it. Yes or no? Understanding, guys? So these are very, very important. So just have a look once. And the examples I gave torque and the angular momentum. Okay. Chalo. So see the next question. Question number 11. A and B are two vectors and theta is the angle between them. So then if they say, so the magnitude of A cross B is equals to root 3 A dot B. This is a A dot B, vector A dot vector B. So the value of theta. So what they said, the magnitude of A cross B is equals to root 3 into A dot B. So magnitude of A cross B is nothing but what? AB sin theta, only magnitude they are asking. So then root 3, what is magnitude of, what is AB, A dot B? AB cos theta. So AB cancel. So sin theta by cos theta, tan theta is equals to root 3. So the theta must be equals to 60 degrees. The theta must be equals to 60 degrees. Option A is the correct one. Understood? Clear? Sure. So next question, see here. So what's the question says? If the angle between the vectors A and B is theta, so value of their product B cross A dot A. So just now we discussed. So the resultant of B cross A will be perpendicular to the individual vectors. It will be perpendicular to A and it will be perpendicular to B as well. So that's why simply we can write B cross A dot A. These two vectors are perpendicular. Yes or no? The resultant, which is a B cross A dot A, they are asking. So the resultant will be perpendicular to both the vectors. This is vector A, this is vector B. So you are finding B cross A, B cross A. So this B cross A resultant is perpendicular to vector B and vector A. So here I am taking here vector A, it's perpendicular. So therefore the dot product must be 0. If they both are perpendicular, obviously option D is the correct one. Clear? Chalo. So again the special cases. So here it is, the printing mistakes, guys. So this is 0 degrees. Okay, so this is 180 degrees, not 1800. And then this is 90 degrees. Okay, chalo. So if you need, you can write it like this. So this is 0 degrees, 180 degrees, 90 degrees. So chalo. So if the angle between the two vectors is 0, so then their cross product will be obviously 0. Why? Because sin 0 is 0, right? Sin 0 is going to be 0 here. Sin 0 is going to be 0. The overall thing, it comes out to be 0, right? So that's clear. And 180, sin 180 is also 0. So that's why A cross B is again 0. So sin 90 is 1. So then their magnitude, A cross B magnitude will be equals to AB. Yes or no? Sin 90, 1. So done. So here one thing you should remember. So if two vectors are parallel, so then their cross product is 0. If A is parallel to B, so then you can say that the A cross B will be equals to 0. You can take. If two vectors are parallel, their cross product is 0. If two vectors are perpendicular, their dot product is 0. If two vectors are perpendicular, so then their dot product is 0. Remember this one. Clear? If two vectors are parallel or anti-parallel, whatever. Either parallel or anti-parallel. So in that case, in both the cases, A cross B is equals to 0. Clear? And what are the properties of cross product? So it is not commutative. So it is not commutative. So the cross product is not commutative. A cross B is not equals to B cross A. But the A cross B magnitude will be equals to the magnitude of B cross A. Magnitude of B cross A. So but we can say that A cross B is equals to minus B cross A, negative of that. So and it is distributive in law. So here A cross B cross plus C is equals to A cross B plus A cross C. We can write this. So this is distributive. And then when you multiply a vector by itself, when you multiply a vector by itself by cross product, so the answer comes out to be 0. So right, it's 0 vector. So you better let it be. It's 0 a vector because A cross A is 0. So the cross product of two vectors is a vector again, right? This 0 is a vector. Okay, this 0 is a vector. Let it be. Okay, now clear this part. Chal. So see, Directly they are asking the question, if A cross B is equals to B cross A. So first, what is A cross B? So which is AB sin theta. Yes or no? So A cross B is equals to B cross A, BA sin theta. So if A cross B is equals to B cross A, so there you can simply cancel them. So see what they are asking, the angle between the two vectors, right? Then the angle between A and B. So they are asking A cross B vector is equals to B cross A. Fine. Okay, 1 minute. A cross B and B cross A, when they will be equal? So whenever the angle between them is pi, right? When they will be equal? When A cross B will become 0, when angle between them is pi. So B cross A will also be 0. So when pi, theta is equals to pi. So this is 0, this is 0. They both will be equal when theta is equals to pi. Direct question. Right? Clear? Sure. So next, see here, what's the next question? Which of the following is a unit vector perpendicular to A and B? So let's write the vector A cross B. We know that it's going to be the magnitude of vector A into magnitude of vector B into sine angle between them. So then this is the magnitude and the direction is given by unit vector. So now which of the following is a unit vector perpendicular to A and B? So the unit vector which is perpendicular to A and B will be obviously A cross B by, so AB sin theta. Yes or no? This unit vector is perpendicular to both. So that's why A cross B by AB sin theta. Just the formula based question. This is a unit vector. They are asking the what is a unit vector. That's it. A cross B by AB sin theta. This unit vector will be perpendicular to both A and both B vectors. Yes? Yes or no? Chalo. So next, so the cross product of orthogonal unit vectors. Let's go for the cross product of orthogonal unit vectors. The cross product of orthogonal unit vectors. So see here. So the first thing is, I can say the I cross I is 0, J cross J is 0 because sine 0 is 0, right? J cross J is 0 and then K cross K is 0. K cross K is 0. So whereas in dot product, I dot I is 1, J dot J is 1, K dot K is 1. Okay, but in cross product, it's reverse. I dot I 0, J dot J 0, K dot K 0. Okay. Now, so to understand the what is I cross J and what is J cross I and what is J cross K and what is K cross J and what is I cross K and what is K cross I. So the simple trick, the trick that you have to follow is draw I cap, J cap, K cap like this in a circular. So then the clockwise take it as positive, anti-clockwise take it as negative. Clockwise take it as positive and then anti-clockwise take it as negative. So let me show you. See here. So first move clockwise. I cross J, clockwise I cross J will result in K. Clockwise positive plus K. Okay. Then so then next J cross K which is equals to I cap clockwise. So then K cross I which is J cap. So this is the clockwise direction. If you take anti-clockwise, let's suppose, so if you take anti-clockwise like this, so first come from here. So J cross K, you are going anti-clockwise. So J cross I. So the next one K, which K you should take anti-clockwise means minus. So minus K cap and then I cross K. So the next one J comes. So anti-clockwise minus J. So then K cross J. So which comes minus I cap. Clear? So the simple way to do the cross product of orthogonal unit vectors. Hope you guys understood. So I cross I 0, j cross j 0, k cross k 0 for cross product. So whereas I clockwise take the positive, anti-clockwise take the negative. So just remember this trick. You can write this easily. Okay? Chalo. So if there are two vectors, so let's suppose the vector A is ax I cap. This is the ax here. This is ax down. So this is ax I cap, bx I cap, ay j cap, by j cap, az k cap, bz k cap. So then a cross b, we can do it by the determinant method. So a cross b, we can do it by the determinant method. So what is this determinant method? So let me show you here. So I can write a cross b as simply, so first write the I cap, so then write the minus j cap, okay, so then write the k cap. So I cap, first write the I cap, so then do the minus j cap, then k cap. So then write the coefficients of the first vectors I cap, so then j cap coefficient ay, so k cap coefficient az. So then write the second vectors bx, by and then bz. Okay, so now, so the a cross b will be given by, so simply first write the I cap. So while considering the I cap, what you do is close that row, column, close that row, just for your imagination, close that row and close that column, close that row, close that column, I cap. Okay, so then, so what you do is remaining 4, you consider A, B, C, D. So this is A, B, C, D and write AD minus BC. So what is AD minus BC here? So see here. So if you write, if you close this one, AD, this is the A, this is D, this is B, this is C. So AD minus BC, which is AY BZ minus, so AZ BY, so I cap. Okay, na? I consider I, close that column, close that row. So then remaining 4 terms, take them as A, B, C, D. So then do the AD minus BC. That's the determinant. You already learning in the matrices, right? So next. So then take next one, minus j cap. So minus j cap, close that column, close that row. Row, column close. So then this is A, this is B, this is C, this is D. So then AD is AX BZ minus AZ BX j cap. Okay, na? So minus j cap, I wrote that minus in the starting itself. So plus k cap. So let's write the k cap at the end. So then k column, k row, close it. So this is A, B, C, D. So AD, what is AD? AX BY minus BC, AY BX. So this is k cap. So that's it. Okay, na? So this is the determinant method we had to follow to do the cross product of two given vectors. Done. Chalo, next. So what's the question says? See here. So there is find the torque. Force is given and R is given. So the force vector is what? Minus 3 I cap plus j cap. So this is plus 5k cap, I guess. Here it is, printing is given wrong. This is considered it as 5k cap. Okay. And then 7 I cap, 3j cap plus 3k cap. So then R is equals to 7 I cap plus 3j cap plus k cap. So then what is torque? Torque is equals to R cross F. So R cross F. So what you do? You just do the determinant method. So take I cap, here minus j cap, here k cap. So the first vector, it has minus 3. So then coefficient of j is 1, coefficient of k is 5. So then here it is 7, 3 and 1. So can you simply do the procedure? So just simply find what is R cross F. R cross F. So you just write I cap into AD minus BC. What is AD? 1 minus 15. Close that column, close that row. AD means 1 into 1. So minus 15. So then minus j cap into, So minus j cap into AD is minus 3 minus 5 into 7, 35, right? So 35. So then plus k cap into, k cap means AD minus 9. So then minus 7. Yes or no? So then R cross F will be equals to minus 14 I cap. So this is minus half minus plus 38 j cap. So this is minus 16 k cap. Okay na? Minus 14 I cap plus 38 j cap. So minus 16 k cap. So this is a R cross F. Yes or no? So the R cross F. So I guess some values are given wrong here. We did torque is equals to R cross F only, right? So R is this one, F is this one. Yes. So you understood the procedure, right? Some here I guess some signs are given wrong. I took this as minus 3i only. So plus j plus 5k. So then 7i cap plus 3j cap plus k cap. So this option should come out. So but some values or signs are given wrong. So just check the signs, but understand the procedure same. Okay. So while printing they gave something wrong here. Okay now. So we did the procedure correct only. I cap minus j cap k cap. So here it's going to be minus 3 1 5. This is 7 3 1. Yes. So then I cap into AD minus BC 1 minus 15 correct only, and then minus j cap into so what's that 50 this is close this row column. So AD minus BC minus 3, so minus 35. Yes, correct. So then k cap, so which is minus 9 minus 7. Yes, correct only. So then just follow the procedure guys. Okay. So the only thing that's matching with the values is this one. There some signs are given wrong, that's it. Okay. Chal. So then if two vectors are parallel, let's suppose there is a vector A which is given as AX I cap plus AY j cap plus AZ k cap. Okay, then there is a vector B which is BX I cap plus BY j cap plus BZ k cap. So these two vectors are parallel. So then their cross product is 0. We know that their cross product A cross B will be equals to 0. So then you can simply write that, so the AX, their X components AX by BX is equals to AY by BY is equals to AZ by BZ. This trick you can use to find the unknown values. Okay, so I'll take one question so that you will understand better. Just understand the logic. So we'll take the question. See here. So what's the question says? These are the two vectors which are parallel to each other. So then simply I can say its x component and its x components are common. So 2 by minus 4 must be equals to 3 by minus 3 must be equals to, so here minus 1 by lambda. So 2 minus 4, 3 minus 3, and then minus 1 here lambda. So any two you can take. So let's consider these two, so that I can write minus 3 by minus 3, 3 by minus 3 is equals to minus 1 by lambda. So from here lambda is equal, this is going to be minus 1, so then minus 1 cancel, so the lambda must be equals to 1. Option A. Clear? Understood guys? Everyone? Clear this part? Or else you can take this part also. So 2 by minus 4 is equals to minus 1 by lambda. Okay na? So take this part also. So then, so if you have to form a parallelogram with the two given vectors, so then A cross B will be like the area of the parallelogram is given by the magnitude of A cross B. Okay now. So if triangle is formed with the two given vectors, so then the area of the triangle is given by half into magnitude of A cross B. Okay now. So the area of parallelogram formed by two vectors A and B, which is magnitude of A cross B. And then if you need area of the triangle formed by two vectors, so which is half into, so A cross B. Clear? Understood guys? Sure. So next, calculate the area of the triangle determined by the two vectors. A vector is given, B vector is given. Simply what you do is So the area of the triangle is half into the magnitude of A cross B. You know how to find the magnitude of A cross B, right? So then multiply it with 1 by 2. So take this question as a homework. So this is a homework 3. Okay. So that's it, guys. So with this we have completed the entire vectors concept in detail. So from tomorrow I'll start the relative velocity. So where first we'll see the relative velocity in 1D, and then we'll go for the relative velocity in 2-dimensional motion. So where reverse swimmer questions we'll solve, umbrella woman questions or umbrella man questions we'll solve, and wind and aeroplane problems we'll solve. So all these kind of and collision type of questions based on the relative velocity. So all these questions we are going to solve in the next 2 sessions, that is relative velocity based topics. Okay. So till then, keep studying. All the very best, guys. Bye. Take care.